Hey, Algebra 2, we're going to learn how to solve quadratics and identify some key features. Alright, so let's say that we have a quadratic. And let's say that we're looking at number 1. So like x squared minus 2x minus 3. So remember, if there's no number in front of it, then there's an invisible 1. And so this is my a term right here. It's always x squared's coefficient. The rule is if a is positive, then your graph is going to look like this. And it's going to open up. And this right here, there's my vertex. And your vertex is a minimum. If your a is negative, then your graph looks like this, and it opens down. And in that case, your vertex is right there at the top, and your vertex is a maximum. The AOS is called the axis of symmetry. The axis of symmetry is an imaginary line that goes through the vertex and cuts your parabola into two equal halves that mirror each other. So it cuts your parabola in half. It goes through the vertex. And the equation is always x equals some number, and that number is always the x coordinate of your vertex. We have a few formulas up here. So to find your axis of symmetry, there's this formula, negative b over 2a. We will use it. And then to find your vertex, so it's the formula for the axis of symmetry. And then this function notation is basically plug that number into your original equation and solve for y, and then that's how you find your y coordinate of your vertex. I found this graph a few years ago that some of my former students thought was pretty helpful to start learning this. So I'm going to teach you on this, and then we're just going to do it normal. So this indicates that it's always in standard form. So this is the equation we're going to graph. And so a is 1, b is negative 2, and c is negative 3. This right here is a fun fact. Your c is always your y-intercept. We will use that in a moment. All right, so I like to know what my graph looks like. So a is a positive number. So a is a positive number. Therefore, my graph will open up. So we better get a graph that looks like that when all is said and done. The first thing that we do is we find the axis of symmetry by using the formula negative b over 2a. So the negative here in front of it means you take that sign and you change it. So the opposite of negative 2 is 2. And then a is 1. So you have 2 over 2 times 1. Do the math on the bottom. And then simplify it. So your axis of symmetry is the equation x equals 1. I like sketching it in because I like knowing how it mirrors each other. So this is your axis of symmetry line. Step 2 says find the vertex, or the y part of the vertex anyway. Plug x in and solve for y. So into my original equation right here, I have y equals 1 squared minus 2 times 1 minus 3. So you can just work it out or put it in your calculator, whatever works. That's 1 minus 2 minus 3, which equals -4. So parts 1 and 2 work together, and they tell you that where your vertex is. It is at 1, -4. So your vertex is the only point on your axis of symmetry. The next thing that you're going to do is plot C, which is your y-intercept. And if you go up there, it says C is -3, because that's a -3 right there. So there's my y-axis, so I just plotted that one and reflected over. So if this is 1 to the left, that means it has a mirror image 1 to the right of it. Step 4, find your x-intercepts. You can either factor or use the quadratic formula. So we want to figure out where the graph crosses the x-axis. So we just came off of a factoring unit. So we have y equals x squared minus 2x minus 3. So we're going to get rid of that y, and we plug a 0 in its spot, and that's how we find the zeros of it. So we need factors of -3 that add up to -2. And that would be -3 and 1. So this factors as x minus 3, x plus 1. Set your factors equal to 0 and solve, and x equals 3 and -1. All right, so here's my x-axis. So solutions and x-intercepts are the same thing. So you have a point right here at -1 and another one right there at 3. So it's starting to have a good shape. So once you have 5 points, and you have your x and your y-intercepts, you should just be able to connect the dots and finish it off. And then here are all the key features you have to be able to know. All right, so your y-intercept, we got that from our C, and it is at 0, -3. And I don't know why I forgot to put the x-intercept on this version. So the x-intercepts we found are right there from here. So that is at 3, 0 and -1, 0. Your domain. So that means those are your x values. What could you plug in? And that was all real numbers. And we say all real numbers go from -infinity to infinity. The range. So the range are your y values. So you got to come over here and look. So we have a minimum value right here at -4, and then your y's keep going up and up and up. So in Algebra 1, I would have said y is greater than or equal to -4. And to write it in that other notation, it goes from -4 to infinity. All right, so we have a vertex right here, and that is at the lowest point. So that is a minimum because it is at the lowest point. So we have a min at -4. And so your min or max is always the y of your vertex. So I got that number because that is the y-coordinate of your vertex. Let's do another one. All right, so up at the top, it has the steps on it. Pull this up a little bit more. There we go. All right, so I don't have I don't have a C term, so you can always add in a filler 0 for whatever you do not have. So I can see A as -1, I can see B as 6, and I see C as 0. My A is a negative number, so I know that it's going to open down because A is negative. What is my axis of symmetry? You find your axis of symmetry by doing -b over 2a. So let's see. So then we're going to find the axis of symmetry by doing -b over 2a. So b is 6, so that means -6 over 2 times -1. So -6 divided by a -2 equals a +3. So your axis of symmetry is the line x equals 3. Alright, so there's my axis of symmetry. Step 2 is you're going to take that number and you're going to plug it in and you're going to find the y part of the vertex now. So negative parenthesis 3 squared plus 6 times 3. So you have to be super careful when you have a negative out in front because your order of operations says that you square the number first and then you change the sign. So this is -9 plus 18, which equals +9. So steps 1 and 2 tell you where your vertex is, and it is at 3, 9. Step 3 is to plot C and reflect it. So we added in a filler 0 there. So we have our y-intercept here at the origin at 0, 0. It's 1, 2, 3 away, and then I'm going to reflect it 1, 2, 3 to the other side. So the y-intercept is at 0, 0. The x-intercept. So step 4, we need some more points. So to find the x-intercept, I'm going to set y equal to 0, so I have -x squared plus 6x. This is a GCF kind of a problem. So I'm going to factor out a -x, because I always factor out whatever the leading coefficient is, so their signs match. When you divide variables, you subtract exponent, so that gets me an x. And then I have a positive divided by a negative equals a -6. So then you write your two equations. -x equals 0, so that's just x equals 0. And then x minus 6 equals 0. And x equals 6, which I actually knew from that prior step. So I have x-intercepts at 0, 0 and 6, 0. So then if you wanted some extra points, you can always make a table to get yourself some extra points. So I have my vertex at 3, 9. So if you go on either side, if you go 2 and 4, then those numbers will end up matching. So when I plug 2 in, you get negative parenthesis 2 squared plus 6 times 2. So that's -4 plus 12, which equals 8. So you can plot a point at 2, 8 and then reflect it over at 4, 8. So once you have 5 points, you have enough to connect the dots and make your parabola. Your domain is your x values. It is always going to be -infinity to infinity on a quadratic because you can plug any number in for x that you want to. Your range. So here's your vertex up at 3, 9. So 9 seems to be the maximum point up here. So this vertex is a maximum. And it's going down to infinity from there. So recall that we write that as negative infinity to 9. And this one has a max at 9. And then we'll do one more here. All right, so there's A, B, and C. I know that my graph is going to open up because A is a positive number. Step 1, find your axis of symmetry by doing negative B over 2A. So the opposite of negative 4 is 4. And then A is 2. So now I have 4 divided by 4, which equals 1. Kind of sketch in your axis of symmetry. Step 2, plug that number in for x to get the y part of your vertex. So I have 2 times 1 squared minus 4 times 1 plus 3. You can plug that directly into your calculator, or see, 1 squared is 1 times 2 is 2. Minus 4 plus 3. 2 minus 4 is negative 2, plus 3 equals 1. So that means you have a vertex at 1, 1. Y-intercept. So step 3 is plot C, which is your y-intercept, and reflect it. So this is 1 away from the axis of symmetry. I'm going to reflect it to the other side. So my y-intercept is at 0, 3. Your x-intercept. So normally I would factor it, or maybe make a table of values. But I have 3 points, and my vertex is above the x-axis. So in this case, my x-intercepts are none. My domain is always negative infinity to infinity. My vertex here is at 1, 1. So the 1 is the smallest value that I get, and then it's going up to infinity from there. So it's going 1 to infinity. And that vertex is at the lowest point. The lowest point is a minimum at 1. And we will do some more later.